So let's talk about some of the features you might expect to find in virtualization products, whether they're Type 1 or Type 2 hypervisors. So virtualization software packages can include features for sharing hardware, manning the virtual computer environments. So we're going to talk about some of these different features. So hardware features, motherboard and processor support. So the latest hypervisors support BIOS for either BIOS or UEFI. Some hypervisors only have BIOS support. So even though the hardware might be using UEFI, in the virtual machine, you'll see the standard good old-fashioned BIOS screen, but some newer ones also can do UEFI. Most hypervisors support virtual CPUs for guest VMs, which again is the hardware has to support that feature. As far as memory goes, data center virtualization products can include support for SLAT, ballooning, overcommitment, page sharing. I'll just kind of talk a little bit, kind of from a high level here, that you would think that memory utilization would be as simple as, taking a finite amount of memory and dividing it up amongst the guest operating systems. But one of the things that happens is not everyone's using all the memory at the same time. So you can have things like overcommitment where even though perhaps I only have 10 gigs of total memory, maybe I commit 12 gigs to my various operating systems or my various virtual machines, knowing that at any given time, no one's going to be using all 12 of those gigs. They'll be using it at different times. So sometimes they do support those types of features so that you can more efficiently utilize the hardware that you have. Most virtualization platforms will have some kind of administration or a console that you can use to create and remove virtual machines, configure the settings for your virtual machines, which we'll talk about later on, manage the storage and network devices, starting and stopping your VMs. User consoles provide a window to the desktop of the operating system running the virtual machine. The administrative console will typically provide some interface for configuring, creating, and managing these virtual environments. And sometimes you even have web-based consoles, which you can use a web page to access the VMs. Most of the cloud environments that we'll talk about make use of a web-based console for accessing your virtual machines. So the administrative console, usually you have control over the COM and printer ports. So you'll have some kind of control over which virtual machines are using those ports or how they're shared. You'll have control over the USB ports and peripheral devices and how they're connected to the virtual machines, which ones are able to use those. Typically, you can configure how it uses CD and DVD devices from the virtual machine. You can even mount ISOs directly to a virtual machine, which is nice. So if you have an ISO file of a CD, there's no reason to actually burn it to a CD. You could just mount it directly as if it were a CD to a virtual machine, which is actually a lot easier. And this is a screenshot of Oracle's Hyper-V, Microsoft's Hyper-V, showing the configuration where you can point to an ISO as your CD-ROM drive so that you could, say, boot from an OS disk. So as far as disk support, these are the different types of formats that you can have for your virtual disk. There's the VDI format, which is native to Oracle's VirtualBox. You have the VMDK format, which is for VMware, the VHD format, which is for Microsoft's Virtual PC, and then VHDX, which is for Hyper-V. So these are the default formats for those disks. There are some disk formats that are standardized that can be used amongst those different virtualization platforms. So in many cases, you could take a VDI disk and you can use that with a virtual machine from VMware, or you can import it in Microsoft. And likewise, you could take a Microsoft disk and you could use it in VMware. So some of these can kind of interchange between these different vendors. So as far as disk support goes, I'm showing you in the video here. You should be seeing how you have different hypervisors accessing these different disks on different computers. They can use SANs and NASs, and we'll talk about that briefly here in a little bit. So this image file is usually stored on a local disk drive. It says here IDE disk drive, which is of course not really the case. It's usually just whatever the local disk is, whatever technology the local disk is. It doesn't necessarily have to be IDE. It could be SAS or SATA or even a SAN or a NAS. So data center virtualization supports VM files on a shared network drive, such as a storage area network or a network attached storage. And the nice thing about that is we can number one, you can very quickly move machines between different VM servers. All you have to do is point them to the SAN or to the NAS, and they're able to read those files and they're able to run those virtual machines. But also you can use those enterprise storage platforms for the storage of your virtual machines, which typically take up a lot of space, more than you would want to have in a single server. So it is, if you're going to do a virtualized environment in a data center, you almost have to have a SAN or a NAS infrastructure to support that. As far as disk support goes, you have when you create your virtual disk, there's two options usually. The first two options you'll have to decide are whether to use a fixed size for your virtual disks or a dynamic. A fixed size is generally you get a bit of a performance gain by having a fixed size, but if you're not using most of the disk, it's going to use all of that space. When you set it to dynamic, it's only going to the file size on the guest OS is going to be basically is going to be the same size as the amount of data that's in your virtual machine, and it will grow over time as you store more data. So it's a lot more efficient. But in order to facilitate that growth, there has to be some processing and some things have to happen. So you do have a bit of a performance hit when you use dynamic, although it's really not that much though for desktop applications. The fixed size virtual disks have better performance, as I said before. So as far as saving a VM state, so this is an important feature. This is one of those really nice features about VMs is you can save a state of a virtual machine at any given time, and you can always come back to that state, unlike a physical machine, which is much more difficult to do that. Non-persistent disks, when you make changes to a virtual machine, they're only used in the current session. You can take snapshots, which allow you to return to a virtual machine at a specific point in time if you have some problem. So a lot of times we'll take a snapshot of a machine before we make any major changes. That way we could go back to the snapshot prior to making any of those changes. Parenting and cloning, so virtual machine parenting allows you to have a master copy of a virtual machine that you can use for distribution to other users. So for example, you could build a master for 2008 server, and anytime somebody needs to provision a 2008 server, it's provisioned from that master, from that parent copy. In VMware, the parent is called a linked clone, which we talked about earlier. And of course, you can make templates that you can use to deploy different operating systems and different platforms and so forth. If you're going to move a virtual machine, so if you have the same hypervisor and you want to move a virtual machine, it should be as easy as copying the files from one host computer to the other and then spinning up your virtual machine. But when you're going between different hypervisors, sometimes you have to use a compatible file format. The OVF format, or Open Virtualization Format, is one that's industry-wide. So if you use that format for your virtual disk, you should be able to move it between different vendors. Although, like anything else in life, there are no guarantees, but you should be able to move between different vendors. And as I said before, in many cases, the different virtualization platforms support other vendors' formats. For example, VMware can support the Oracle's VirtualBox and Hyper-V, and Hyper-V can support virtual VMware and so forth. So a lot of times you can move these around. When we virtualize our systems, not only do we have to virtualize the disk and virtualize all the hardware, but the network is also virtualized. So we also have to know a few things about that. So when a virtual machine is in local mode or host-only mode in VMware, its emulated NIC is plugged into a virtual machine. So in bridge mode, basically in bridge mode, you are connecting directly to the local area network when you're using bridge mode. So when you see that option, if you want your virtual machine to connect to the network just like any other computer on the network, you would use bridge mode to do that. Shared NAT mode is where your virtual machine can access outside networks, but it does so through the guest or through the host operating system. So that would be a shared NAT mode. So you'll have both of those options when you install a VM, and you have to decide which of those you prefer, depending on what your goals are. And we'll talk about virtual networking later on, especially when we talk about clouds. We'll talk about networking in the cloud as well when we do cloud computing. So some migration tools, you can import VM files from other sources, creating a VM environment based on a physical computer. So you can take a physical computer and convert it to a virtual machine. So you can build a physical machine and then use that to convert to VMware, for example, with something like the VMware converter. So lots of little features like that to move your virtual machines. So that's it. That's everything we discuss in this unit as far as an introduction to virtualization. And we'll talk about each of these topics in a bit more detail over the coming 3 units, where we discuss virtualization again in a little bit more detail. Don't forget to watch some of the videos on cloud computing as well. I'm going to introduce some of the concepts with cloud computing, which is really covered later on in the first part of the course.